Boeing puts space industry in danger. 7 weeks after Boeing's CST-100 Starliner failed to reach the International Space Station as planned during its first orbital flight test, NASA and Boeing officials disclosed the preliminary results of an investigation into what went wrong. The uncrewed Starliner spacecraft launched atop an Atlas V rocket on December 20, 2019, on a mission to dock with the International Space Station. The mission was designed to demonstrate the new spacecraft's ability to safely transport astronauts to and from the orbiting laboratory. However, Starliner failed to reach the correct orbit and instead spent the next 2 days circling Earth alone before executing a picture-perfect landing in New Mexico's White Sands Missile Range on December 22. On Friday, February 7, NASA Administrator Jim Bridenstine said that an independent review team has identified several issues during the orbital flight test mission, particularly when it comes to the spacecraft's software. Along with the previously disclosed error with Starliner's onboard timer, a second software issue could have potentially led to a slight but problematic collision of two of the spacecraft's components, investigators determined. The first software issue was identified shortly after Starliner launched, when the vehicle failed to execute an orbit insertion burn. Boeing soon discovered that the spacecraft's onboard timing system, called a mission elapse timer, had erroneously pulled an incorrect time from the Atlas V rocket nearly 11 hours before liftoff. Starliner was supposed to retrieve that information from the rocket during the final countdown period before liftoff, and because this step happened prematurely, Starliner's internal clock had the incorrect time. Then a second software problem was discovered before the spacecraft's return to Earth, and this glitch could have potentially led to a collision between Starliner's crew module and its service module, which are designed to separate in orbit before the crew module lands. This problem, which Boeing officials called a valve mapping error, had to do with the software that tells Starliner's crew module and service module to separate before landing. The service module's thrusters are responsible for conducting the deorbit burn that takes Starliner out of orbit, sending it back to Earth for landing. After the deorbit burn, the service module detaches from the crew module and safely splashes down into the Pacific Ocean. If Boeing hadn't caught that glitch before Starliner came back to Earth, the two modules could have bumped into each other after separation, which could have destabilized the crew module during a critical point in its descent. The thruster's uneven firing would cause the service module, which is a piece of a cylinder, to come away from the crew module and recontact, or bump back into it. Jim Chilton, Senior Vice President for Boeing Space, said during the teleconference, "Bad things can happen as a result of that eventuality. It's hard to say where the service module would have bumped, but nothing good can come from those two spacecraft bumping back in, so they sent the software to make sure that couldn't happen." A third major problem that Starliner encountered during its orbital flight test was not related to the spacecraft's software, but rather had to do with interference that disrupted communications between ground controllers and Starliner. When ground controllers tried to manually command Starliner to conduct an orbit insertion burn after the timing error prevented that from happening automatically, they were unable to communicate with the spacecraft in a timely manner. Communications between Starliner and ground control are relayed via NASA's network of tracking and data relay satellites, but high noise interfered with those signals. The investigative review team is still working to determine the exact cause of this interference, but it appears to be associated with cell phone towers. While the independent review of Starliner's OFT issues is still underway, NASA expects to have the final report by the end of February. NASA has not yet decided whether to conduct a second orbital flight test before using Starliner to fly astronauts to the International Space Station. The software issues are likely only symptoms. They are not the real problem. The real problem is that numerous process escapes in the design, development and test cycle for software.